Okay. Hopefully there weren't any crazy surprises. I think the averages were like in the low 90s for milestone 1 and 2, and then um, somewhere in the lower 80s actually for milestone 3. So milestone 3 was actually the tougher one there, I think, in coming up with working tests, linting errors. I know I kind of undersold how hard it would be. That's my bad. But overall, that was worth the least as well. So hopefully, um, nothing crazy and surprising when you saw your grade. If there was, then again, come to office hours. And then your group proposal should have been submitted last night. I know I didn't make it very clear that all members were expected to submit. If you didn't submit, please just fill out that form. The main reason I'm asking you to do that is because there's an individual question on there where I just kind of ask for feedback about your group. So I would want everybody's perspectives from the entire group. So fill that out. If you didn't, that's okay. You're not going to lose points, but try to do that today. Your first IM meeting is this week, so make sure that you sent the proposal doc to them as well as the agenda. If your IM hasn't gotten back to you about your meeting time, then let me know so I can confirm with them. But I think everybody, they at least replied the first time to everybody. And let's see what else. So sprint 1 is going to be due April 19th for you guys. That's in 2 weeks. So make sure that you're starting work early. So you don't want to be working on this the last few days. It's going to be a mess if everybody has to work on the last few days at the same time. So try to best split up the work and then work in parallel as you're going. And then final note, I think course evaluations opened yesterday and they're open till April 11th. So if you want to, then go ahead and fill that out on Canvas or the app. Any questions with logistics, IMs, proposal, grades? So for the meeting, the PM sets the agenda and kind of keeps everybody on time. You don't, if you want to talk for the entire agenda and like share the proposal and stuff, then you can. Otherwise, you can also kind of tell like, hey, I want Ian to go over the proposal. I want Pranavi to go over like how we're splitting up work. Just plan it out beforehand, however you want to do it. Yeah, you're just leading, setting the agenda, and keeping everybody on time. And for this first meeting, everybody's agenda should pretty much look the same based on what I put in the specs. Okay, if you have more questions, you can just ask me as I keep going. So we're going to be talking about continuous integration. This is, you might have heard of this practice. It's a development practice that kind of basically is talking about how multiple developers integrate code into this like shared repository. So your GitHub repo. And this is something that becomes important as you're coding more frequently and with more people all in the same code base. So obviously, this is pretty relevant for us when we're doing our group project, especially. And I'm going to play this YouTube video because I think this guy did a really good job of just explaining how, or just like the importance of continuous integration and how it works. Let me just play it. Let me know if you can hear. Give me a thumbs up or just type in the chat.
I'm Eric Minnick with IBM Cloud. I want to tell you a little bit about continuous integration today. This is a development practice that just about everybody thinks they're doing, but it's widely misunderstood. So I want to start by talking about, the bad old days before we had it, what problem we're trying to solve, and what this does for us and what it's really about. So let's start with our old school approach, where we've got a couple of developers. They're probably on a team of 30 or 50. We got Alice and Bob, and they're working on their own features, and they're going to keep separate on their own features for a long time, right? So, you know, they're writing some bits of new code here. You know, maybe they're deleting a line of code here or there, what have you. And their plan is that they're going to get their features to work against the code base, and then a couple of weeks or months later, they're going to integrate their work together. They're going to merge their work together. They're going to say, my code, your code's got to come together. It's all got to work. Now, in this world, you could have a situation where Alice and Bob, well, they changed the same line of code here, right? And maybe Alice changed this code, but then Bob deleted it. And so this gets really awkward really fast when you just try to algorithmically combine it, right? You get what's known as a merge conflict. This gets worse because it might be that some code up here interferes with some code down here. They just don't work together and you've got bugs. And this will happen here within just one file, but in the real world, it's not just two developers working on the same file. There's thousands of files or millions in an application. There's tens of developers involved, and they're doing this over weeks and weeks. And so reconciling all of these problems, big mess, called merge hell. And so it's like, well, what do we do to avoid merge hell? This is how we got here. Well, we start, and we'll have Alice writing some code again, right? Alice writes her code. Cool. As soon as she has something that works even a little bit, her feature is not done, but she's got code that works, that doesn't break things. She submits that into source control. Bob pulls down the same code before he starts working, right? He always is working off the latest. Alice is always submitting hers in. Bob makes his change, right? Maybe he deletes a line of code. Great. Alice comes back, she's working on another part of her feature, she's working on another feature. She grabs Bob's code. Cool. And now they're working on these things together, and the likelihood that they're both working on the same thing at the same time and that they conflict is pretty small. And if they do hit that, it's all on code they've worked on in the last day, right? They can sit together and they can reconcile this thing. It's no big deal. And so the core principle that we're seeing here, one of my favorite things in software development, because it's so counterintuitive, is that if it hurts, do it often, and it won't hurt so much. And that helps us get rid of the big bogey here, right? Which is, you know, we're going to not have merge hell. We don't like merge hell. Get rid of that. Okay, so that's fix number one. Now, this does create a new problem, though, right? Have a whole bunch of people constantly checking in code into the code base. Things are going to break, right? It's not going to compile. There's going to be bugs that weren't there yesterday. And you have this kind of continuous integration led to continuously broken problem, and that's sad. So what do? Well, we put some automation in, right? And it's always watching the code, keeping an eye on it. And whenever a change happens, it says, okay, let me grab that code. I'm going to build it. And then I'm going to test it, right? I'm going to run my unit tests. So if there's any change, build it, test it. If anything in here fails, then we email the team, right? We let Alice, Bob, the whole team know, say, hey, there were 2 new changes since last time I did a build. Looks like both Alice and Bob touched this thing. It's broken now. They need to go fix the code base. Good. So now we've got a safety net that enables continuous integration. Good. The other thing that we're getting, though, is that we always have this build, right? So whenever the test team wants to go test it in more depth, right, to run a heavier level of test than the unit testing that we're doing here, they've got a build they know compiles. And it's the newest stuff, right? So that's our other key benefit coming out of continuous integration, is that we always have a testable build. So there you go. Continuous integration was addressing the old way of infrequent integration, saying if it hurts, we're going to do it continuously, we're going to do it a lot. That avoids merge hell, keeps our developers productive, and it gives us a constantly testable build. So that's continuous integration in a nutshell. Thank you.
Okay, I think he explained it pretty well. Obviously, you guys are gonna run into merge conflicts, but the key is if you're more continuously integrating. So if you're checking in code more often and in smaller pieces, it doesn't have to be a finished feature or a finished user story, then the likelihood of kind of running into conflicts is going to go down significantly. And this is kind of what you're going to see at any company. You're always encouraged to be breaking down your code as small as possible, and then always like pushing it to the main branch as often as you can, basically. And then that like second part is about adding automation in to basically have a better workflow, catch more errors and things like that. So are there any questions from what he was talking about in the video so far? You can ask as I go through the practices. So these are some of the best practices that you're going to see in terms of continuous integration. Continuous integration is also a big part of DevOps, which is like a whole like kind of methodology in its own way, similar to Agile or something like that. So you might have been hearing about DevOps. It's become a word that's used more and more often these days. So one thing to just know is that CI is a key part of it. Oops. Some of the key practices, one is maintaining a single source repository. So we've been doing that. You're going to be doing that. You're setting up your GitHub repo that's kind of shared across your team. We don't need to talk about builds really. That's not too relevant here. Building is kind of transforming your code into executable code. So I don't know if you work with Java, but usually you do like Java C to like compile it into an executable, and then you would run the code. This is what building is talking about. So automating that process. We haven't really had to do that in any form in our case, so I'm leaving those out. The other green ones I'm going to talk about. So making it easy for anyone to get the latest version, that kind of has to do with if you're pushing the latest version of your code as often as possible, then you're making it easier for the rest of the people on your team to be able to pull that down and work from the latest kind of work that you've added. And then you want everybody to be able to see what's happening. So again, you kind of want as much transparency as possible in terms of the progress in your code, what you're working on. That comes from pushing often to your repository, as well as updating your Kanban board. So what we talked about last class, in order to kind of show the progress of your tasks that you've done. And the final one, actually automating deployment. So this can speed up deployment in terms of not needing to manually push from Heroku every time you make changes or push to Heroku. So that's why I had kind of asked you to try out in milestone 3, automating that so that whatever is on the whatever latest commit is on your main branch is automatically going to go to Heroku. This is going to be useful for you as a team as well, because you don't need to kind of figure out like, oh, did somebody push to Heroku with the latest stuff? You know, it's automatically happening. You don't really need to think about that. Now, these two red ones here are keys that we haven't really talked about much. Making your build self-testing. So basically making your code self-testing. We implemented tests in milestone 3, but if you want to, let's say that you made good tests and they're really testing your code and its functionality. Whenever you make changes, you're probably going to want to run those tests to make sure that you haven't broken any of those functionalities accidentally. But you would have to remember yourself to run like Python unit tests in order to see that all of them are still passing. But obviously, if you have like 20 tests, you're not necessarily going to remember them all. You have client tests, you have server tests. So we're leaving room for human error here, and people being like forgetting about testing and things like that. So if you make it self-testing, then you automate this process. You take out the fact that maybe somebody's going to forget. You also make it faster for you as a developer because you don't need to run these tests and execute them. So overall, your development process speeds up and may catch errors that you might have missed out on. So that's why you want to automate this here. And kind of a corollary to that is you want to test in a clone of the production environment. So if you're automating the test, you might not necessarily be automating it on your own computer because your own computer is not always on and ready to execute them. You might want to use like a virtual machine or something that is kind of mirroring what the production environment is going to look like and running the tests on there. And this is going to lead me to talking about some tools that help out here. So this is where like automated CI/CD comes. CI is continuous integration. CD is continuous delivery, or continuous deployment. I think it's interchangeable. There's a lot of examples that do this sort of process for you. So Circle CI is one of them, Travis CI, Jenkins. You might have heard of these tools. We were already doing CD of our main branch when we were using Heroku. We don't need to talk about kind of the building side of things. As I was saying, it's nothing too relevant. It's more for like the compiled languages, Java, C++. And then for automating kind of the testing side of things, we're actually going to be using GitHub Actions. So we could be using Circle CI, Travis CI. These are technologies that have been used often in the past. I know in this class, we used Circle CI last semester, but I'm actually going to move us to use GitHub Actions this semester for two main reasons. One of them is there's no kind of third-party integration here. So we don't need to, all of our code's already on GitHub. So we don't need to make a separate account now for a separate service and kind of connect them together. It's already all in one place, which makes things a lot easier for us. Another benefit is that GitHub Actions, it basically has a lot of useful templates and code that we can borrow from online. GitHub in general is a place where people are sharing code and all sorts of things. So that kind of extends naturally. But what actually, let me first kind of go over what GitHub Actions is. So very generally, it's just a way where you can automatically trigger some workflow, so run some actions when certain events happen in GitHub. For us, in our case, when we want to automate tests, then the kind of workflow that I want us to set up in project 3 is whenever we push to our main branch. So whenever we merge code from your development branch into main, or whenever you in any way you push something to your branch, I basically want you to automatically run your linter and your unit tests. And GitHub Actions basically is going to allow you to set up this flow and do that for you. And this is going to help because now every time that you push some code to GitHub, you're going to be able to monitor whether this code is successfully passing your linter and your tests instead of needing to remember to run those commands every time on your own. This also helps on a team because you can see other people's pushes and see if those pass the tests or not. So this kind of allows everybody to be on the same page in terms of how your code is doing and progressing. Okay, so I'm going to show how this looks now. And it's actually a pretty easy process. So I tried it for the first time with GitHub Actions yesterday, and it took me like an hour to really get everything going. The way it works is you have these tabs up here. So there's actions. And if you go to actions, actually, let me show you on a different repository. So if you go to actions here, it's basically going to let you get started with a workflow. And they're gonna actually have a lot of workflows that are kind of templates that you can base off of. So you could be like, oh, I'm using a Node app, so maybe I should just set up this automated workflow. In my case, though, I'm gonna ask you to set this up yourself just so we can kind of customize this better. And what's gonna happen is it's gonna take you to a new file, and they've kind of created most of the skeleton on this file already. With comments. And this is going to help explain like what every step in this workflow is going to do. But I already wrote one, so let me go back to what I wrote. So that new file that they create, once you edit it and stuff and actually commit it, it's going to add a new folder that's like .github/workflows. And anything inside of this folder is going to be automatically run based on GitHub actions. So let me show you one example of what I wrote. This is it's a YAML file, so it's .yml. This is just like a weird syntax that I honestly haven't really used before, but you're basically setting key value pairs here, and you're setting some sort of configuration that tells GitHub how to run the workflow that you want. So again, the goal of what I want to do in this file is to basically automatically run my test. And in this case, I want to automatically run my Python test, so the unit test that I'm writing. And here's how it kind of works. So you have this on key that you set, and the on key is basically saying I can add any events underneath that, and those events are going to trigger this workflow that I have below. So I'm saying on push. So whenever I push to this list of branches, and here I'm just putting like the main branch that I was working on, the default branch. For you, it might be main or something else, or you could do multiple branches if you wanted. And also on pull requests, which I'm going to talk about, I basically want to trigger some events. And then here's the actual workflow that's going to run. So you have this jobs key, and again, they give you a skeleton, so you don't need to remember all of this. I'm going to have a single job that I'm going to call test here. I could call it whatever I want. And then here are kind of the criteria and the actions that I run for this job. So I was basically talking about how you want to test on a production environment. So when GitHub automatically runs these tests for you, they're not running it on your own local machine because they can't rely on your local machine. Maybe it's off, maybe they don't have access to it basically. So they use their own machines. They have their own virtual machines that they're running, and they let you run your automated tests, or they will automatically run your tests on their own machines. So here you can kind of configure that machine. I can say it's running on Ubuntu latest. So I'm basically saying, use this default Linux machine that they use. I have this strategy matrix, which is basically saying, I want to run my tests for these different versions of my Python. So I want to make sure that this will work regardless of if you're using Python 3.6, 3.7, 3.8, and then it would run this job or this kind of flow on all of those versions. So you could similarly do this for anything. So if you want to test different versions of, let's say, Node, you could do that as well. And then here are the kind of steps that I want to run within my actual workflow. So these lines were more for setting up your system that you're going to be running on. This isn't really going to change for anybody. And then these lines are kind of the actual commands that you want to automatically run on these events. So here, this is basically a list in YAML where you have dashes, and each dash is an item in this list. And in this list, the first one is basically to check out. So it's saying uses actions checkout at V2. Uses is basically saying I'm using a workflow that somebody else has already defined. So GitHub has some predefined workflows that you can use and leverage from them, similar to like using an API. They've written out this workflow for you. You don't need to rewrite it. And Hemant, do you have a question? I think you're, oh, okay, you're good. And this specific one right here that you're using is basically just going to check out your repository so that you have the latest code. So you want the virtual machine to have access to the code that you're going to test. So that's what this does here. The second one in this list is basically setting up Python. So you can set the name field if you want. I'm basically using, again, another default action that's predefined by GitHub, which is going to set up all the Python, basically install the Python like environment that you would want on this virtual machine. And it's going to make sure that it does it for every single version that you've defined up here. So again, this is more setup stuff. This isn't going to change for most people. This is probably the more interesting part. These last three steps in our workflow, the first one is going to kind of install dependencies. So again, if you're running tests, let's say you need Pylint or you need Socket.io, you need to make sure that you've installed all of these based on your same requirements file. So this is very similar to Heroku when you want to just download all the requirements on a different machine. And then here's my actual test that I care about. So one, I want to make sure that the linter is run every time. This is going to allow us to, your entire team to see on this commit, looks like these lints were failing or throwing an error. And then I want to run my actual unit tests. So what we're saying here is basically, this is the name of my step. And then for that step, I want to run this command. So you can think of it just as a terminal, and your virtual machine is going to run this line automatically. Similar to like a proc file when you're saying, I want you to run python app.py to start up my app. Here you're telling this virtual machine to run unit test or Pylint or whatever you want. Any questions with what you're seeing here? I know it's a funky syntax, but you're going to get used to it. Okay, cool. Yeah, so you're leading me to the next part that I'm going to talk about. Where do you actually see these errors? So for that, once you've actually committed this file, then GitHub knows there's this workflow to run now, and it's going to be doing that. Now, how do I actually see the workflow? There's two places you could see it. So one is simply in my commits. I'm saying that I want to run this workflow every time you push to this branch. So I could go to this branch, look at my commits, and you see this little X here, or like a check. And this is basically giving you the status of the workflow, the continuous integration every time this each commit was kind of pushed. If I click here, it'll say like all tech checks were passed. Let's say it tried to do for each Python version 3.6, 3.7, 3.8 on the push event. It was trying to run my test job. And then I could go into details now. And in details, it's actually going to tell me all of the steps that it ran. So we were basically saying it's going to set up the job. It's going to run this checkout thing in order to get the Git contents. It's going to set up Python. It's going to install the dependencies. It's going to run the tests. So here you can actually see the output from the terminal. It's running this command. When it runs it, it says ran one test, okay. And then it was just kind of printing out the stuff that I had included in the test. And similarly, if you were doing a lint, I can show you that as well, what would happen. So one way of finding that was in the commits. The other way is if you just go to the actions tab, then it's going to list out all the runs that it's done from these workflows. So based on the event and the branch and the timing, you can see the different workflows. So let's say I want to only look at the server ones because that's what I was showing you in my example. I could click the server and then see these are the ones that are going on here. So let's see when I added linting right here. Now, how do we see errors? So I could click on one of these where there's the error and it's going to open it up right here. And here we can see the errors that kind of made this show up as an X on this workflow. It tried running pylint, but when it did it, then it's seeing all of these things come out. So trailing white space, docstring, whatever. And it's basically saying error here because it was throwing some stuff. Obviously, you can decide as a team which ones you want to ignore and keep. But once you've decided that, then you're basically going to have to make sure that you include that in your pylint RC file so that the automatic workflow covers that as well. And this is something that you're going to see at any company. There's always going to be this sort of continuous integration workflow where when you submit your code in or you try to check it in or merge it, then on those events, you're going to see that all your tests are being run, your linters being run, and errors are being thrown. And this allows everybody to understand and monitor how that's going. And this is something that I'm going to expect that you add to your GitHub repo from the start so that you kind of have this full workflow going on. And this should really take not too long because you'll be able to pretty much copy the files that I've written here and just change them to your specific requirements. So maybe you don't want to include all pylint things, or maybe you're using a different linter or a different testing framework, then you could change it up here in terms of your commands. Any questions? Any other questions? I've similarly done another one here for the client side of things. So on my node side of things, I can basically run npm test, npm or npx ESLint, and I could have a workflow with that as well. Okay, cool. So I just included the steps here for how you can set this up for yourself in your repository once you do. And I also, on the specs, I included a video if you want to get even deeper and add new workflows for your team, you could go ahead and do that. So here we're doing tests, but it doesn't necessarily have to be tests. There's a ton of other things that you could kind of add on there. Okay, so second thing I want to talk about, aside from CI, is kind of basically this workflow of how we can review our code. Right now, the kind of way that you're probably thinking about doing things is you create your feature on your feature branch of your repository. You add your code, you test it out, make sure it works. Then you would probably pull the latest updates to main and then try merging in your feature branch. So this is fine. This is kind of the way that you had to do it in project 2 and project 1. But there is something missing here, and I'm just going to tell you. We're basically assuming that we are merging good code into main. So when you decide to merge your feature into the official main branch that's kind of getting deployed to Heroku, you're assuming that everything works well, you tested it out enough, but that's kind of, and you're also assuming that you have good code quality. But that's obviously not going to be the case all the time. And you definitely want to get another pair of eyes on your code before you kind of officially do that, especially for the more important features or larger kind of changes that you're adding. Whenever you're on a team, you want to be able to kind of collaborate and review each other's code. And this is what we do with pull requests. And pretty much at any company you join, you're never just going to be merging your code into their main branch on your own. So there's always going to be some checks and balances, some steps before that to make sure that your code is solid enough to officially be added. So just the fact that you tested it out and you think it works is never enough for a large company where you could potentially risk, breaking something and losing tons of money. And this is why we're going to kind of have this process of pull requesting where you can review each other's code before you merge it. And I am going to show another demo now about that. This is actually from a student from last year in 490, Akil Samarth, and he had explained this really well, so I was just going to use this directly. And both of these videos I've put onto our class playlist so that you can look back on these as well. Okay, I'm going to play it.
My name is Akil, and I'll be talking about remote repos and pull requests. So first of all, let's go ahead and review a typical one-person workflow like we used in the previous projects. Typically what you'd do when you wanted to add something or make a code change is you'd create a new branch from master, you'd make whatever changes you wanted and test those changes, and then when you were done, you'd merge all that back into master. Now this works fine for one person, but it can cause serious issues if you're working with a team. Some questions you might have in a team are, what if someone else has made changes to master before you got on? What if you and someone else are modifying the same code? How can you safely merge things back into master without breaking anything? In general, a team can pose several challenges that you don't run into when you're working by yourself, like how can the team code together without breaking everything, and how can the team work together effectively while taking advantage of the fact that there's multiple people? The answer: remote repos and pull requests. So first of all, remote repos are something we used in the other projects, but not to their full extent. A remote repo, if you don't know, is a normal repository which contains files, branches, codes, etc. that's hosted on something like GitHub. You can have multiple local repos connected to a single shared remote repo, which allows multiple people to easily work on the same project. Remote repos contain a really cool feature called remote branches, and just like how a remote repo tracks and stores the work done on local repos, remote branches track individual local branches. So some examples of this are, you might have a remote development branch set up to track a local branch that you push changes to and keep track of your work. And also there's the remote master branch, which should hopefully contain the latest stable version of your project that local master branches can update from. So now let's see that in action. So we're going to hop into Cloud9 and GitHub just to see how remote branches work. So I'm here in my GitHub where, as you can see, I've created this fake project, just has a couple of files in it. What I'm going to do is I'm going to go ahead and clone this repo into my Cloud9 using git clone. And I'm going to go ahead and cd into it. Now in here you can see that these files are all there, and there's a couple of empty files. Now I'm going to go ahead and check out a branch just like you would normally, and we'll call it test feature. So now we're on this new branch, and I'm just going to start making some code changes. So maybe I'll add in a hello world function. Let's go ahead and test it. And it seems to work. Okay, now I'll go ahead and commit just like you would normally. There we go. And now this is where the remote branch comes in. Where what I'm going to do is I'm going to type git push, but you'll see that it doesn't work. And that's because we don't currently have a remote branch set up to track this branch. So you can type in this command or instead of doing set upstream, you can also just do -u, and this will actually create a remote branch for you and set everything up so that this local branch tracks the remote branch. And there we go. So now we've pushed, and if we go back into GitHub, we can see, if we refresh the page, that under master we now also have this test feature branch. So let's go ahead and see if our changes are there. So this is under the master branch. Go ahead and do test feature, and there we go, it's right there. So now if I make another code change, again, always test. Yep, that seems to work. So I'm going to go ahead and commit that. Now I just have to type git push. I don't have to worry about the other switches or anything. I just type git push and it works just like that. And if I hop on over to GitHub, you can see that bam, my changes are right there. And this is how you can utilize remote branches to keep track of any changes on your local branch. And I want you to notice that this is actually a completely separate branch. This is not the master branch, and so this makes sure that the master branch stays nice and clean while you do development on a separate branch. That's how remote branches work. Now that we've seen remote branches in action, you might be asking yourself, how do we actually merge these in? For example, when you're done developing a feature and you've pushed to a remote branch, how do you actually get that into master so everyone else can use it? The other thing is, how can you easily let your teammates know that you're about to modify master and you're adding in a new feature? The answer to this is pull requests. So the best way I think to explain pull requests is just by showing them to you. So let's go ahead and hop back into Cloud9 and GitHub and go ahead and see how pull requests actually work. So for this demo on pull requests, I'm back here on GitHub in my test projects repo. So this is just a sample repo with a couple of files in it, and I already have it cloned into my Cloud9. So now let's say I want to make some changes. The first thing that I'm going to do is do git pull. Now what git pull does is it'll update your local master from the remote. So if your teammates have been making any changes to master, then git pull will make sure that all of those changes get pulled into your local master. Here obviously there's no changes, so it says already up to date, but this is something that you should always do whenever you're ready to create a new branch. Now that we've done git pull, we're going to go ahead and check out a new branch just like you would normally, and I'll call it new feature. So I'm on my new branch. I'll go ahead and just make some simple changes. So I'll make a hello world function maybe, just like I did in the other demo. And sure, we'll just do that. Let's go ahead and test our file, make sure it runs. And it does, but we never called the function. This is why you always want to test. And there we go. It works as expected. So now I'm going to go ahead and commit this change. So we'll say new change. And there we go, it's committed. And now I'm going to go ahead and push it to a remote branch. And again, if you don't know what this is, take a look at the remote branches demo from a little earlier. So there we go. Now we should have a remote branch, and if we come into GitHub, we should see that this new feature branch shows up. And if we go into that file, yep, there we go, our changes are all there. So now that's great and all, but how do we actually get this into master? Now normally what you'd do is you do git checkout master on your Cloud9 and then do a git merge. But this is not what you want to do in this pull request workflow. Instead, we're actually going to go over to GitHub and merge this remote branch into the remote master. So how do we do that? As you can see up top, there's a little button here that says pull requests. So we'll click that and we'll click on new pull request. Now what this will do is it'll give us two options. It'll give us a branch that we want to merge into as well as a branch to merge. So in our case, I'm going to select new feature into master, and that's what the arrow indicates, that we're going to merge new feature into master. So I'm going to go ahead and create that pull request, give it a name, and obviously for your real project, make sure you're giving it a descriptive name, and go ahead and create that pull request. Now at this point, you'll end up in this screen. And in fact, this is something that anyone on your team can see. So if anyone on your team goes to this pull request menu now you can see an open pull request that we just created. So they can click on this, anyone can come on this and leave comments, for example, give you feedback. And in general, this is something that allows your entire team to be up to date with whatever changes you've made. Your team and yourself can see whatever commits you've made, but the most important part is right here in Files Changed. In Files Changed, you can see a list of all the changes that have been made in this branch as compared to your branch that you're merging into. As you can see, we deleted the print hello world from master, and we added in this hello world function as well as the function call. And in here, your teammates can come in and review changes. So you can maybe add in a comment. Maybe I want to add in a comment. Obviously, you can leave feedback for your peers, and if there's something wrong, you can let them know. Then I'll go ahead and click Finish Review. And there we go. So now again, it shows up in this main screen right here that I've just reviewed something, in this case my own work, but this would obviously be your teammates if you were doing this for real, like in Project 3. And this allows you...
One thing I just want to mention here, if you see in the pull request at the bottom, there is something saying continuous integration has not been set up. GitHub Actions and other apps can be used to do this. So if you did have that workflow that I just talked about set up, then every time you create a pull request, it's actually also going to automatically run your tests and your linter and show it here. So these two things kind of work well together.
To make sure that everything is clean and everything is well reviewed. Once you're satisfied and someone has reviewed and you're ready to merge, then you can do merge pull request. So I'll go ahead and click this now. And again, so you can probably just leave this as is and do confirm merge. And there we go. So now you can see that this changes to merged. So you can see this pops up and it says that I merged that commit into master now. And now if we go back into code, we'll see on our master, if we go into that file, there we go. These changes are now in master. So now if we go back into Cloud9 and we do a git pull, just like we did before, there we go. All of these changes get pulled, and now anytime one of your teammates does a git pull on master, these changes will reflect in their master. So this is how you use pull requests to merge changes into master. You should never be merging to master directly or locally. You should always be using pull requests to make sure that your code stays nice and clean. Now that we've seen pull requests in action, let me tell you about some of their benefits. Pull requests allow teammates to know about and review changes before they go into master. They also allow everyone to be on the same page about what code changes are currently being implemented on the project. Also, they keep the master branch generally clean and stable, and they make sure that the quality of the code is high by making sure that all changes going into master are seen by multiple people. If you've never used the pull request workflow before, here's a couple tips I have for you. 1. You never ever want to modify the master branch directly. The remote master should only be updated through pull requests like we saw before, and this is to make sure that it stays nice and clean and that all changes are reviewed, and the local master should then pull from the remote master. Other than this, the master branches should never change. So for example, you should never be committing to master, you should never merge directly into master locally, none of that. You should only modify master through pull requests and git pull. The other thing is, you always want to pull the latest remote master using git pull before checking out a new branch. If you don't do this, you could end up with an older version of master, and this could cause merge conflicts later on. So you really want to call git pull before checking out a new branch. Finally, make sure that there is only one person using a branch at a time. You really don't want two people working on the same branch because that can cause all sorts of problems. In general, you don't want to touch other people's branches unless you're reviewing their work. Finally, let's go over some key takeaways. Remote repos allow multiple people to work together on a project and they maintain a backup of your code. Pull requests are one of the most important features of remote repos and they allow for safe, reliable merging of code. When these things are used properly, these tools allow for efficient and high-quality development by a team, and they're used all over the place in the industry for this reason. Thanks for watching.
Okay. think Akhil did a really good job of explaining this flow. I know this is not something you had to do so far because it didn't really make sense when you're working on your own. Yeah, Gavin, so that link it's on the slides and it's also in the same YouTube playlist, and I'll add it to Canvas too, so it's everywhere. It's also on the specs actually. This is something super useful to get in a hang of right now. Separate from just the benefit of working on a team and not having to deal with confusion about who's working on what, who's changing code when. The other benefit is that you're definitely going to need to use this workflow at another company. So the companies that I've worked at so far, whether it was using GitHub or not, there was some sort of reviewing workflow where you can never just push directly to master. You push to your branch, you create a pull request for your branch, somebody else reviews it, and then you actually merge it. And this is going to make you a better engineer as well, because maybe somebody remembered like some best practices that you didn't include. They can then give you feedback on that and help you kind of improve a better way of writing your code before you officially check it in onto your main branch. They might also spot bugs. There's all sorts of things that you could do here. So I'm not going to require you to do a pull request for every single commit, but I'm going to highly, highly encourage it. What I will say though, is if I don't see at least one pull request submitted by each team member, then you're not going to get points for using version control. And I'm hoping that once you've done it once or twice, you're going to get in the flow and you're actually going to want to use it versus just doing a plain merge locally or something like that. And I'm pretty sure it's going to end up saving you from a lot of headaches. Any questions with the pull requests that we're seeing? How many commits before a pull request? Good question, Chris. So I'm not necessarily going to say how many commits before the pull request, but what I will say is you don't want your pull request to be changing more than, let's say, like 200 lines of code. So 200 lines is the general rule at Facebook. So I'll include the same one here. If you're passing that 200 limit, then that's just going to be a huge pain for other people to review. And it's also going to it's probably going to lead to you creating larger features and not breaking it down into smaller chunks like you should be. So for that reason, I would say, if there's 5 commits, 40 lines each, then that's fine. It'll add up to 200. The end goal though, at the very end, you want to make sure that there's not more than 200 lines of code change. Yep, so that could be 1 commit as well. That'd be okay. So to recap, here's the kind of workflow that you want to be thinking about. You're going to be working on your code on a separate branch. So your feature, that could be a user story, that could be a part of a user story. You kind of decide depending on how big it is. You're always going to want to pull latest changes from your main branch into your local. Yeah, so Michael's asking, would it cause problems if you pull it from main before you check out a new branch? Okay, so I kind of made this a little unclear here, but if you're creating a new branch, you first want to pull from main. That is definitely like the right way to go, because you have the most updated main and then you're branching off of that. In this flow here, I'm kind of saying, let's say that you already have an existing branch, you're not creating a new branch. If that's the case and you created this branch, let's say yesterday, and main has changed since then you would check out into that branch, but you would also want to pull its latest changes from main so that you're still working with the latest code. So in this workflow, if let's say you have this branch created already, you would go into your branch, make sure you have the latest changes from main. This is going to merge those changes into your code. And this kind of helps you make sure that you're working with the latest. You would make your commits. There can be 1 or more. and then you would push that branch to GitHub. And you can push it whenever, as you're working on it, you can keep pushing it. But once you're, fully happy with this code, you've tested it, and you think that it's ready to be reviewed, then you would make the actual pull request to merge it into main. And then ideally, some team member would then review it from your team. They can check it off if it looks good to go. They could leave some comments, and then you would kind of go back and address them. And then finally, you can merge it. So that's the flow. And then for deployment, hopefully you would have already set automatic deployment. So that would mean any changes you've merged into main are automatically going to go to Heroku, where you can then test to make sure things are working. So this is the kind of flow that I'm going to be expecting here. Definitely try out pull requests early, and hopefully you're going to start liking them enough that you'll just keep using them throughout. And you as a team can decide, we only want to do pull requests, or we'll only do pull requests for large changes. I'll let you guys kind of decide that based on your comfort. Exactly, Michael. So that's actually something I can add in. After you've kind of merged successfully into your main branch, you would definitely want to just delete that local branch now, clean that up, and then work off of a new branch that you create from main. Okay, and just some best practices in general: commit early, commit often, merge early, merge often. So do these things as often as you can, in small chunks, and that's gonna help nobody kind of being blindsided, like, oh, I was working on like 1,000 lines of code over this week, but I didn't tell anybody about it, and now I'm just checking it in at the end. So you want to, instead of that, you would want to do, oh, I worked on like 50 lines of code today. Things are working, they're not done. I'm just going to push that so that other people are aware of it. Okay. All right, so now I'm going to give you guys some group work time. Some goals that I would say for today are to create your GitHub repo if you haven't already. So create that shared one. One person will make it on their private account and then add the others as collaborators. You can use React Starter as the base if you'd like to, if you're using the same stack. Also, make sure you've set your commit history name. So on the commit, your real name should show up so that we can then make sure that you've been contributing. You can also set up your Kanban board in order to track progress of who's working on what. And then you can kind of add stories to that board based on how you're splitting up work between your team. These are all steps that I've included on the specs, so you'll find it there. Okay, so same thing as last time. I'm gonna create the 10 rooms and you will join according to your number. Okay, just open them, go to the breakout rooms option in the menu, and then go ahead and join. Again, if you've tried finding your room and you still need help, maybe the option's not there, then let me know and I'll manually add you. Okay, Catherine just added you, Jacob. Chirag. Okay, who else? Let's see. Jacob to 7. Kevin to 5. Okay, Glorian, group 8. Mont, group 8. Okay. Okay. Gavin, Jose, Joseph, Luca, Abhishek, do you need help joining your room? Which room, Gavin? Sorry. Joseph and 7, okay. Okay, forgot your number. Who are you with? Let me know one of your member names and I'll find them. Jose, Luca, what groups are you in? I can add you. Okay, Gavin, you're with Glorian. Okay, let's see. Glorian's in group 8. So you're 8, Gavin. Just adding you now. Okay, I think everybody's coming back now. Cool. All right, hopefully you got a chance to coordinate a little more. Start the setup of your GitHub. That's okay if you didn't, fully do it or anything. But any questions with this flow? Any confusions? One thing to actually note, you don't need to have one user story per person. So maybe it's a larger user story. You could split that up down into subtasks as well. Okay. All right, I'll stay back for 10 minutes if there's specific questions, but otherwise, hopefully start splitting up that work and start on sprint 1. You have 2 weeks, and next class, I'm going to talk about either the Google Login API or just like REST APIs in general. Haven't decided yet, but I'll see you Thursday. Have a good week.
Quick question. What we should do during the first mission? The first meeting is in the project specs, right?
Exactly, Rainfist. So just introduce yourselves, share your proposal, and get any feedback from the mentor about it.
Okay. All right. Thank you.
Yep.
Neman, for the Heroku part, one team member has to do like one app on Heroku, right? And
yeah, exactly. So one person will deploy, like set up the automatic deployment, and then the rest of you shouldn't need to do anything.
okay, so on the personal application Heroku, yeah.
Yeah, you can add people as collaborators to that Heroku link, but I don't really know what more you can do with that.
Oh, okay, yeah.
Yeah.
Thank you, Neman.
Yep, Oscar. Okay.
Professor,
Yeah.
I have a question.
Hey, Xavier.
I was just wondering. So for the auto lint, when it runs a virtual machine and it installs like Pylint with the requirements, that
Yep.
means that we don't necessarily need to have the lints installed on our environment when we're programming, right? Because the virtual machine will get it installed automatically with the requirements.txt.
Yes, exactly. It's good to have the linter on your local so you can catch things before you push, but it will be able to do it separately.
Okay, good. Because I was told that was crazy, and I was like, I thought this is how it works. All right, thank you.
Yep, totally. Thanks, Rupesh. Take care. Bye, Christian. Other questions?